Hello everyone! In this video, we will present the main improvements to the 2023 version of STRAP. In this version, we focused on the user experience and developed new options that simplify modeling. Let's start with general improvements. Until now, in order to perform dynamic rotate and rotate the model in space, you had to select it in the toolbar or hold down the control button. From now on, this can be done by clicking and holding the left mouse button. The selection process has been significantly improved. We will demonstrate this by deleting existing elements. From now on, when moving to the selection area, a menu with selection options no longer appears in the center of the screen. Instead, the selection options menu appears on the right. The program immediately enters the selection mode of individual elements by default. While in this mode, by clicking and dragging the left mouse button, you can select elements by window. By clicking and holding the right mouse button, you can select elements by polygon. We will press and hold the right mouse button and release it where we want to place the first side of the polygon. We will continue creating the polygon by clicking on the left mouse button and double-clicking to finish the selection. In addition, it is also possible to choose elements using a conventional mesh, polygon, and a window similar to the 2022 version. Using the rotate button, we can rotate the model in the selection area, and when we are finished, we click the end button. Using add and remove, we can add and subtract elements from our selection. By pressing select all, we select all elements, and by pressing end selection, our selection is complete. By clicking the right mouse button on an intersection, we will have the option to display the plane of the intersection. If our node is inside a submodel, this option will show us the submodel to which the node belongs. The intersection plane is defined as the plane perpendicular to the height axis defined in the software. By default, the height axis in the space frame model is defined as the x3 axis. As a result, this option will display the nodes x1 and x2 plane. The default height axis can be found in Model List, Setup, Additional. This setting will apply to every newly created model. If we have already created a model and we want to change its height axis, we will navigate to Remove, Display Selected Levels, and change the height direction. There has been added an icon that allows you to remove and restore elements from display. On the left, select the action we want to perform. Remove elements, display only selected elements, restore removed elements, and restore all removed elements. On the right side, select which elements we want to return and then click OK. For the purpose of the example, let's remove several elements. Select Remove, click on Elements on the right, and click OK. Now select a number of random elements and click on the letter E to complete the selection. As can be seen, these elements have been removed. To restore the removed elements, press the same button again, Restore, OK. The removed elements will be shown. Choosing them will restore them. Likewise, we can re-add removed elements by clicking on the Restore All button. We have added a button that allows us to remove and restore all submodels from display. In the current version, it is possible to set the default size for the beam results graph by pressing Model List, Setup, Results. Under Diagram Size, we can define the size of the beam results graph, where the maximum value is 5 and the minimum is 0.1. The undo and redo commands have been rewritten and their algorithms have been improved. Now, these commands are much more reliable and less likely to encounter errors. While working on your model, the program automatically performs a backup. The backup is performed in the background without interfering with the work process. In the event of a power outage, damage to the model's files, or the software closing due to an error message, the model can be restored from a backup file. The model can be restored by clicking on Models, selecting the model, and clicking on File, Recover Model Geometry. By pressing the Move button under the Nodes menu, a new option has been added: Scale Nodes Coordinates. Using this option, we can scale the coordinates of the structure by a factor of our choice. Select the entire structure and click on the letter E to finish the selection. Select a reference point and enter the value 2 to scale the structure coordinates by 2. After clicking OK, it appears that the model is twice the size. In the same menu, under Move and Rotate Nodes, after selecting the entire model, a new option was added. This option is Select one node and a global axis. Our model can now be rotated about the global axis and the reference point, at an angle to our definition. Click OK and choose a reference point. We will select it again and rotate the structure by 45 degrees. Under Beam and Element Cross-Section Numbers display, you can choose to display the beam cross-section number and the element cross-section number only once for each continuous beam and each continuous mesh. A variety of operations can now be applied on elements within submodels from the main model. You can delete and assign sections to beams inside submodels. Press on Beams Properties, select the desired section, and press on Assign. After making sure the Submodels button is marked on the right, you can select beams in the submodels. Click on Render and make sure that the beam's cross-section has been changed. Moreover, you can create releases for beams in submodels. Select Releases, set the desired releases, and click OK. Similar to the previous option, after making sure that the Submodels button is checked, releases can be applied to the beams of our choice. You can also define the flange location of beams in submodels. By clicking on Render, you can see that there are beams in the submodels defined as T-beams. Press on Local Axis, define flange location, and choose the flange to be assigned to the bottom of the beams. Select desired beams in the submodels. As you can see, the location of the flange has been changed. In the toolbar, arrows have been added under some of the icons. They allow defining parameters related to the display of those icons. Arrows have been added for section number view, restraints view, springs view, render view, releases view, rigid links view, and geometry check. In the load module, when defining or editing loads, an option to add notes to the load cases has been added. Under the Combinations tab, when printing or displaying combinations, by clicking on Combination Definition, we will be presented with combinations and load groups defined in the same table. Under Combination List, the defined combinations will appear, and below that, in Group Definition, all the load groups defined in the model will appear. After transferring the results from the Dynamics or Bridge model, it will not be possible to turn the loading cases into active. Click on Deactivate, and you will see that in each of the Earthquake and the Bridge loads, it is not possible to turn the loads into active. This option will allow us to solve the model for a static solution after bringing the results from the Bridge and Dynamics model. After defining a global load on a non-rectangular contour line, the load display will be positioned inside the outline, even if the center of the blocking rectangle is outside the outline. Under the Results module in the Reactions display, the program will not reload the reactions with every screen shift, unlike previous versions. It will be possible to rotate the model freely in the model space without any lags. This option will be very useful in large models where it took a lot of time to load all the reactions. From now on, it is possible to check punching at edges and corners of walls located on slabs and located on rafts. In Change Elements Result System menu, a new option was added. X direction defined by two nodes. We will click on the new option and select two nodes that define our new x-axis. After selecting the nodes, select the elements for which we want to define the new x-axis and press on the letter E to finish the selection. X-axis of the element results changed according to our choice. Under the Concrete tab, in the Slab Reinforcement edit, after clicking on the Cancel Changes button, several new options will appear. Changes made to a certain area of the slab can be cancelled by using a selection window. Bars deleted by the user can be returned. Bars added by the user can be deleted. And any changes made to the bar arrangement can be cancelled. While editing the drawings, you can save changes without leaving the drawing by clicking on File, Save. You can set the line width of the lines displayed on screen by navigating to File, Setup, Line Width for Screen, and entering the desired value for line thickness. Entering a value of 0 is equivalent to entering a value of 1. For example, we will enter the value 2 for the bar line width and press OK. exit the concrete module and return to it in order to apply the change. In the steel module, in a similar way to the geometry module, in the upper toolbar, arrows have been added under some of the icons. These arrows allow defining parameters related to the display of those icons. There was added an option to display the major and minor axes in each beam. These axes are used as a reference to defining supports for buckling. In addition, it is possible to display the direction of the positive z-axis in each beam. The z-axis is used as a reference to setting support for major axis bending. In Display Capacity button, you can select for which type of results to display the beam capacity for. An option has been added to choose which intermediate supports to display on the screen, as well as whether to show beams defined as combined beams or not. We added the option to display a selected parameter, for example, the cross-section of the beams or anything else from the list. By clicking on Supports, in the Support Types selection area, images were added to illustrate the different types of supports, with the option of displaying the major, minor, and positive z-axis. Support assigning is made simpler and easier than ever. In addition, the Update Support option was added. By clicking the first button, you can update all the intermediate supports in beams to our choice, as defined below. And by pressing the second button, supports can be customized for a selected beam. For example, let's click on the first button and select the upper continuous beam. It seems that all the supports will change in accordance to what we choose. Now we will click on the second option and select a beam. You can see all the supports defined along the beam. By clicking on each of the supports and using the support definition option on the right, you can change the support types. In the Dynamics model, in the Response Spectrum setting, acceleration values can be entered according to periods and not only according to frequencies. In addition, you can paste values that was previously copied from an Excel table. Thank you all for listening.